This section is an absolute value. So let's talk about the definition of absolute value first. So what happens when you have the absolute value of a number? Let's say absolute value of 3. The absolute value of -3. What you're measuring is the distance. Let's say this is 3, this is -3. Absolute value measures the distance from 0 to the point. So what's the distance between 0 and 3? 3. What's the distance between -3 and 0? It's still 3. So all this to say that absolute value is always positive because it measures distance. Now the function of absolute value is defined like this, and it looks like a V. This is like the basic shape. This is where we start. This is your beginning. It's centered at the origin. And then you can move it around using the transformation. So like this is the basic one here in blue. And then you take, let's say this one, you move it, the -3 moves it 3 to the right. Here you moved it up 4, 3 to the right, and then the 2 did a vertical stretch on it. So on. So here's different transformations, and we have covered transformations on previous sections. So I'm not going to stay a lot of time on that, on how to write them. Write the equation for the graph. So here's the vertex of the function of the absolute value. So what I'm going to measure is what happened. It's supposed to be here in the center, and it moved to right, and it moved 1 down. So when I write the function, it would be the absolute value. When it moves to the right is -2 inside and the -1. So I observe the graph first and then I work from there. When they ask you to sketch the graph, again, we can move the vertex. We know it's supposed to start here. Excuse me. It's going to go 2 to the right and 4 down. So it's going to start right here. Now, because it does have a vertical stretch, this is impossible to move unless you pick a point. So I'm going to pick a point here to work from. I'm going to say x equals 1. So what would the y be? And that is going to help you also on my open math. My open math is probably going to ask you for just the vertex, so that point I just plotted, and then one more point. So this is my one more point situation. This is going to be the absolute value of -1. It's always positive, so that's 1. So the point is 1, -2. And then from there, my open math will do the graph for you. It's worth noting here that I could have done, when I plugged it in, I could have done this in the calculator. Let me show you. The Casio has the absolute value right here. So it's going to be shift and this one. And it looks like that. So I would put 1 -2, and then outside goes a 2, and then -4. See? So you could skip the steps and just do it in the calculator if it's usually as ABS on the 84s. It would be math, number here, and then you see ABS on the first one right there. Solving absolute value equations, I usually here, we know that if it's +13, it's the +13 and the -13 that gives you that answer on the absolute value. When it's something like this, I do answer it differently than most books. Basically, I create two equations. I create one equation where you ignore the absolute value. So then I just solve it. And then I divide by 2. Now my other equation, I'm going to change all the signs inside the absolute value. So like the 2x becomes minus 2x. The minus 1 becomes plus 1. And if you're not inside the absolute value, you stay the same. And then I solve it again. And there we go. When you have, like, if you look at the first, this is what I did, it only had the absolute value in the number. When you do have like this with numbers in it, isolate the absolute value first. So I'm going to move the 8 first. And then I'm going to follow the rules I did up there, which is why I'm just ignore the absolute value. And on the other one, I'm going to change the y to a negative, the 6 to a positive. And then same thing here. I'm going to leave the absolute value by itself first. So I'm going to move the 5. Divide by this negative 5. And now this is what I with, so I'm going to ignore it first. Just copy it and just take out that. Divide by 3. And then the other one, I'm going to change the inside, negative 3x plus 1 minus 1 divided by negative 3, negative 2. But it's important that you isolate it first because sometimes that may give you some issues. And as we encounter some examples, I'll let you know. When you have two absolute values, the first one doesn't change. You still do the same thing. You just ignore them. And you solve it. So I'm going to combine the x's. Add the 1 on both sides. And then for the second one, just change the signs on one absolute value, not both. So I'm just going to keep this one the same and change this one's, the second one's. Doesn't matter. You could have changed the other one. You could have changed the 4 and the 1. And you would still get the same answer. Find the x-intercepts of the function. Okay. The x-intercepts of the function is still just solving as if this equals 0. So we're basically setting it equal to 0 and solving. So plus 10, plus 10. Divide by 3. And then it's going to be x plus 2 equals 10 over 3. And then negative x minus 2. Now the x-intercepts are points, or they may ask you to write them as points like this. They're hard to graph. If you have to graph it on my open math and you run into any problems whatsoever, just let me know. But you can see here that the x, you just write them down. Separate them with commas, so I guess you don't have to put the zeros. You would just write the answers. Like 4 over 3, comma, negative 16 over 3. And then to graph it, this moves 2 left, 10 down. Now you can see here it's impossible to do it in this graph, so that graph is not supposed to be there. Sketch this graph. Okay, this one down, 2 right. So it's supposed to start here. If it goes 1 down into to the right, this is where my new point is. Now, because of you have that shrink on outside, you do have to plot some points, at least 1. So let's do 1 point. Let's try 0. You can try any point you want. Now, because see how you have a 2 in the bottom, I will pick an even number. Because if you pick an even number, it will cancel out with the fraction, so you get a nice number to plot. So just heads up, I will pick an even number. So I pick 0, but you could pick 2. You could pick 2, you could pick 4, 6, any even number should work. Don't pick them too big because you have a small graph here. But just so you know. So then my y would be negative 1/2, 0 minus 2 plus 1. And again, I can just put it in my calculator. And I get the answer. If you do it in steps, it would be 1/2 the absolute value of positive. So negative 1 plus 1. So it's 0, 0. That's nice. It's right there. And then with that, my open math should be able to graph it. Looks the same. Is it the same? Yeah, it's the same. And then you have, so yeah, this is section 3.6 on absolute value functions. If you encounter any questions as you're working on my open math, sometimes putting those graphs in there can give you issues. I will more than gladly make you some videos where I show you how to graph on my open math. Just let me know and we can work on that. I just don't want to make this video super long going to my open math and back and forth. But if you need any help with that, just let me know and I can work on those for you.